Good morning, students. Myself, Vijay Shankar from EC Department, Chibral Engineering College. Today, we are going to discuss about the last topic in the last unit, that is inverse transforms examples. Last topic, inverse transform examples. Yesterday, we discussed about the concept of the inverse transform and how many types you have to find out the given function x of z to get the x of n by using the power series, or it is also called as a long division method, partial fraction expansion method, residue method, and convolution integral method. The first one is long division method. Long division method is a simple and does not give a at least form of expression for the time slot x of n. Further, it can be used only if the ROC of given x of z is either in the form of z is greater than or the z is less than. That is, this method is useful when the signal is either right-sided or left-sided. The long division method, or it is a power series method. Power series method is nothing but the sum of minus infinite to infinite. You can do it as a right-sided from 0 to infinite, or left-sided from minus infinite to minus 1. The partial fraction method enables us to determine x of n, making use of our knowledge of some basics of Z transform pairs and Z transform theorems. By using the partial fraction method, directly the expression, what we get, the expression 1 by 1 minus a z inverse. That is one of the Z transform pair or the Z transform theorems according to the a power n x of mu of n. Okay, you can write as a direct equation in terms of time domain function. And coming to the third method, the integral method or residue method requires a knowledge of the theory of the complex variables, but it is powerful and it is also the useful. A residue method, you can find out the series there and apply again the partial fraction method, and you can find out the time domain function. And the last one is a convolution method. The convolution integral method uses convolution property of a Z transform and can be used when given x of z can be written as a product of the two functions. But the given two functions, whether not given the two functions, for the given function x of z, you can write as x1 of z and the x2 of z, and that product individually can find out the convolution and substitute in the convolution integral and find out the final equation in terms of the time domain. So these are the four methods we have used to find out the inverse Z transformation for the given x of z equation. The first method you can take is a long division of the power series method. This method can be preferred when and only when x of n right-sided or it is a left-sided. Z is greater than is a right-sided, Z is less than is a left-sided. Case 1, if I am taking the right-sided, Z is greater than the infinite. So definitely in the function, not it is a greater than, my dear students, it is alpha, it is greater than the alpha something expression, the x a is, if it is a greater than the infinite, nothing is there. Simply it is a variable of alpha, or it is a greater than the a. Alright. Now if I am taking from the right side, it means 0 to infinite x of n z power minus n. expand this function, a long division method, or the power series x of 0 z power 0, x of 1 z power minus 1, and so on, x of infinite z power minus infinite. If z power minus n multiplicand is x of n, the series is x of n is equal to x of 0, x of 1, x of 2, x of 3, and x of so on. And the case 2, the left-sided z is less than the alpha here. The x of z is equal to sum of minus infinity to 0, x of n z power minus n. Actually, it is a minus 1 because it is a discrete. Already we taken this right-sided means from 0, left-sided means it is a minus 1. Okay, whatever it is here, we are explaining about that the series what we have to take the coefficients of the z power minus 1 and z power minus 2 and so on. In this, the z power is a positive power. So on x of minus 3 z power 3 plus x of minus 2 z power 2, x of minus 1 z power 1, and x of 0 z power 0. Here, z power plus n is a multiplicand is for the x of minus n. So the sequence is x of n is x of 3, x of minus 3, x of minus 2, x of minus 1, and x of 0, so on. Okay, this sequence will get positive values of the signal x of 0 to x of infinite. For the left-sided sequence, x of n is the negative values of n values, x of minus 3, minus 2, minus 1, and the 0. Right-sided means it's nothing but the causal signal. For causal, right-sided signals represents the numerators, numerator and the denominator ascending order of z power minus 1. Ascending order of the z power minus 1. For non-causal, left-sided signals represents the numerator and denominator in descending order of z power minus 1. Numerator and the denominator in descending order of the z power minus 1 and ascending order of the z power minus 1 to get the causal and the non-causal signals. Okay. And right-sided z is greater than some variable is alpha, ascending order of z power minus 1. The left-sided is z less than the alpha, descending order of z power minus 1. Let's take one example here. Find the inverse z transformation of the x of z function, the signal x of z, z power 3, 2 into z power 2, z power 1 plus 1 minus 2 into z power minus 1 minus 3 z power minus 2 plus 4 z power minus 3. It's a combination of positive powers of z and the negative powers of z we have. So x of z, according to the definition of the z transformation, x of z is equal to sum of n is equal to minus infinite to infinite x of n z power minus n. So expand from the minus infinite, x of minus 4 to positive powers of z, z power 4, x of minus 3 z cube, x of minus 2 z square, x of minus 1 z, and x of 0 z power 0 plus, and now from here inwards, there's a positive powers of z, negative powers of z, sorry, x of 1 z power minus 1, x of 2 z power minus 2, x of 3 z power minus 3, x of 4 z power minus 4, and so on the infinite. See, z power 4, 3, 2, the positive powers is multiplicand the minus 4, minus 3, minus 2. And z power minus 2, minus 1, and the 0 is x of 2, x of 1, and the x of 0. Okay. Now, these are the series of left-sided, not the left-sided, it is a right-sided because it is a positive powers. Positive powers is a left-sided, and negative powers of z is a right-sided. Got it, my students? And now, the given function is z cube plus 2z square plus z plus 1 minus 2z power minus 1 minus 3 z power minus 2 and 4 z power minus 3. So x of minus 3 is here the positive powers of z cube value. Here you see the z cube is multiplied for the x of minus 3. So x of minus 3 from this function, the value is 1. And x of minus 2 is a multiplication factor of the z square. So z square coefficient is a 2 here. So x of minus 2 is a 2. And x of minus 1, next here the x of minus 1, that is a z power 1 coefficient is a 1, is also z power 1. And here there is a 1 coefficient is a z power 0. Z power 0, that is x of 0 value is a 1. And z power minus 1 coefficient is a x of 1. So x of 1 value is a 2. And z power minus 2 is a minus 2, my students. Z power minus 2 coefficient is a x of 2. That is x of 2 is equal to 3. And z power minus 3 coefficient is a x of 3. That is a 4. So we got the sequences is 1, 2, 1. And the 0 value you can represent it in that sequence as arrow mark. So 1, 2, 1, the sequence is 1, minus 2, minus 3, and the 4. Okay. In this way, you can find out the Z transformation by using a power series or the having negative powers of Z and the positive powers of Z. Take the coefficient, you can substitute in the sequence of x of n and give the arrow mark when n is equal to 0. Got it, my students? And the transformation of delta of n is equal to 1. The transformation of delta of n plus n naught means it's a shifting function. So for the shifting function, you can write as z power n naught, whatever the number of samples is shifted. N plus means that will get the positive powers of z because it is shifted towards the left side. N minus n naught means it is shifted towards the right side with the negative powers of z, z power minus n naught. And you have to write down by using this sequence given the z transformation, and you have to write that in the time domain function. So inverse z transformation of x of z is equal to is already the sequence we got. Now in the another method way to find this sequence in terms of the delta functions, z inverse of the total powers we have, z cube, 2z square, z plus 1 minus the given function. Inverse z transformation of z cube here. Z cube means is a positive powers of z. So with the shifting of how many number of samples here? The 3 samples. So delta of n plus 3. And z square, it is also shifting towards the left side with the 2 samples. So the coefficient is a 2, delta of n plus 2. And here the z is there, z power 1 means how many number of samples if shifted to the left side, 1 sample. So you can write as a delta of n plus 1 and coefficient is 1. And minus 2 into z power minus 1. Z power, here the 1 is there. For 1, delta of 1 only. There's a transformation of delta of 1, delta of n is a 1. 1 inverse the transformation is a delta of n. And negative powers of z is shifting towards the right side with 1 sample is shifted. Delay function 2 into delta of n minus 1. And here the 2 samples minus 3 into delta of n minus 2. And here there is a 4 into delta of n minus 3 and so on. The way to the 2 methods we have, we got the sequence and directly by knowing the standard equation of the z transformation delta of n plus n naught, delta of n minus n naught, apply the inverse z transformation, you can write as in terms of delta impulse function. Got it, my dear students? Two methods we did as in the sequence method, and both are in the same. By taking off positive powers and the negative powers, you can write the time domain function. And again, the sequence is the same: 1, 2, 1, 1, -2, -3, and the 4. Then you go for the division method. We're saying is a division method, long division method also. X of z is equal to 1 by z minus a is given, and its ROC is z is greater than a. Z is greater than a, so it is a right-sided. So represented the numerator and denominator in the ascending powers of z power minus 1. Okay, we already discussed the right-sided means ascending order of z power minus 1. Left-sided means descending order of z power minus 1. Only you have to remember that one. So the given ROC is greater than a, the power series method, or it is a long division method. Because it is a right-sided, remember that it is ascending power of z power minus 1. Okay, x of z is given 1 by z minus c is a positive powers. Take the z as a common, 1 by z into 1 minus a z inverse, and take this in the numerator, z inverse by 1 minus a z inverse. Okay, 1 minus a z inverse, ascending order. Ascending order means -1, -2, -3, and so on, the values we can take here. Okay, so I'm taking here the 1 minus a z inverse with the divide with the z inverse. 1 into, how many times you can divide this? Z inverse multiplied with 1. So z inverse minus a into z power minus 2. Take the minus and the plus, both are get cancelled. A z power minus 2. For 1, you can multiply again a z power minus 2. Multiply with this function with the a z power minus 2, and so on, getting the last function. So what is the coefficient here? Coefficient is z power minus 1, a into z power minus 2, a square z power minus 3, a cube z power minus 4, and so on. Got it, my students? Even here it is also the z transformation only, in terms of z values only. So 1 by z minus a, you can write this as in terms of z power minus 1, a into z power minus 2, a square into z power minus 3, a cube into z power minus 4, and so on. And this function you can read it as a sum of because here the value is minus 1. Minus 1 means z power minus n is there. So start the n is equal to 1 to infinite, because it's a so on we'll get the division method. 1 to infinite. The z value, see here the z power minus 1, minus 2, minus 3, minus 4, and so on. Goes on, it is a minus 1, minus 2. It's a decreasing value. And the what is the a you can observe here? A value is increasing in the ascending order. See a power 0, a power 1, a power 2, a power 3, and so on. So I started here, it is a n is equal to 1 means a power 1 minus 1. Then only you'll get the a. 1 minus 1 is a 0. A power 0 value is a 1. Is a coefficient for the z power minus n. Nothing but z power minus 1. Okay. So a power n minus 1, z power minus 1 is the sum of the equation for the coefficient what we got here. Sum of n is equal to 1 to infinite. A power n minus 1, z power minus n. Got it, my dear students? Now I change this as minus infinite to infinite. Minus infinite to infinite. Because it starts the 1 to infinite. 0 to infinite means it is multiplied with the mu of n. But it starts from the mu of n is equal to 1 means one sample is shifted towards the right side. So what is the mu of step function? Mu of n minus 1 is multiplied for the a power n minus 1. See, actually, sum of n is equal to 0 to infinite means unit step function is there, multiplying. But it started from n is equal to 1 to infinite means The step function is a mu of n minus 1. One sample is shifted towards the right side. One sample. Okay. So mu of n is started from the 0 to infinite as the magnitude is 1. And the mu of n minus 1, see arrow, is a continuous function actually. The diagram 1. So it looks like it's shifting one sample towards the right side. Okay. So change the limitations of n is equal to minus infinite to infinite, a power n minus 1. Write it as a mu of n minus 1 into z power minus n. Got it, minus function. See, what is the x of n now? Is the total function as a x of n, as in the z transformation x of z is equal to. So x of n is equal to a power n minus 1 mu of n minus 1. Mu of n minus 1. What is the sequence now? We got when n is equal to 0, when n is equal to 0, a power minus 1, and n is equal to 1, a power 0, that is a 1, and a square, 2 minus 1 is a, 3 minus 1 is a square, and so on. Got it, my dear students? This is a sequence we'll get for the x of n, and the x of z is given 1 by z minus e. By using the long division method, or it is a right-sided, you have to remember that is ascending order of the powers of the z. Ascending order of the powers of the z power minus 1. Z power minus 1, minus 2, minus 3, minus 4, and so on. Okay. Similarly, if it is ROC is a less than a, the same function if I am taking, but with ROC is a less than a, what do you have to do? Here, first of all, you can remember that the z is less than a, the left-sided, so the representing of the numerator and denominator in descending powers of z power minus 1. Descending powers of z power minus 1. So again, simplify this 1 by z minus a as z inverse by 1 minus a z inverse. Numerator is z inverse, and denominator you can write this as a descending order. Descending order means previously we start from 1 minus a z inverse. Now we can divide the z power minus 1 with minus a z inverse plus 1. Minus a z inverse plus 1. Got it, my dear students? Because it is a descending power of a z power minus 1. So now I am taking the minus a z inverse plus 1. Only the difference here. 1 minus a z inverse plus 1 means now it is descending orders. See here the z power minus 1. Now multiply with how much value to get it is a minus z inverse means 1 by a. A get cancelled and it is a minus, and because it is a plus value, you can keep the minus e. Minus 1 by a is multiplied with its function of minus a z inverse, we'll get the z inverse. 1 with minus 1 by a, so on you can do. You'll get minus 1 by a, minus 1 by a square z power 1, minus 1 by a cube z cube, and so on. Now you can see, observe, you will get is a z powers is a positive powers. Positive powers. Because it is a left-sided, definitely the powers of z is a positive only. So x of z is equal to minus 1 by a, here the z power 0, z power 1, z square, and so on. Z power 0, 0 is there, so we can keep that as a sum of n is equal to 0 to infinite as a z power n. Observe the a value, how it is changes, minus 1 by a square, a cube, and so on. So we started from n is equal to 0 here to get the a value, and it is increases also. Keep the function as a power n plus 1. Substitute a is equal to 0, a power 1, a is equal to 1, a square, and so on. So the given function is minus 1 by a power n plus 1 z power n. Okay, z power n. So actually, in the z transformation definition, it is becomes of z power minus n. Minus n. So change is z power minus n. Power is changes means the limitations changes to the negative values. Or either negative values of summation limitations you can change. In the powers, you can change the positive to negative, negative to the power. So I'm keeping the z power minus n here, and also a power minus n, the powers, whatever the powers we have, changing the positive powers to the negative powers, and change the limitations as 0 to minus infinite. 0 to minus infinite. Got it, my dear students? Because it is a left-sided sequences. And that is equal to sum of n is equal to minus infinite to 0 minus 1 by a power minus n plus 1 z power minus n. And this sequence you can observe minus infinite to 0. If it is a minus infinite to minus 1, the step function is mu of minus n minus 1. But here minus infinite to 0 because it is a folded function. Keep that summation is from minus infinite to infinite. Mu of minus n is multiplied for the x signal minus 1 by a power minus n plus 1. So this is x of n. We got the definition of the z transformation. N is equal to minus infinite to infinite minus 1 by a power minus n plus 1 mu of minus n z power minus n. So only the representation, the mu of minus 1 is a left-sided sequence. Mu of n is a right-sided sequence. From this function, x of z is equal to, what is the signal x of n? Minus 1 by a power minus n plus 1 mu of minus n. Okay. When the given ROC is left-sided means keep the descending order of the powers, descending order of the power of z power minus 1 and ascending order of the powers of minus 1. Okay. And another example, 1 by 1 minus a z inverse. And ROC is given, z is greater than a. 1 by 1 minus a z inverse. ROC is z is greater than a. Now I am taking 1 by 1 minus a z inverse because it is an ascending order of the powers. Ascending order of the powers, we can take 1 by a z inverse with the divide with the 1 and add all the values. And to get here, the coefficient is the negative powers of z only because its ROC is greater than a. Take this power, coefficient 1 is nothing but z power 0 is there. Here the z power 0, z power minus 1 and z square and so on. Okay. And now write the summation. The sum of n is equal to 0 to, because it is z power minus 0, z power minus n. A is a power 0 is a 1, a power 1, a square and so on. A power n, z power minus n. And sum of n is equal to minus infinite to infinite, a power n mu of n z power minus n. Changing of 0 to infinite as minus infinite to infinite by substituting the mu of n, because the value is 1 in the range of 0 to infinite only. So what is the x of n? A power n mu of n. You already know that one. 1 by 1 minus a z inverse is the inverse z transformation for the a of n mu of n only. Got it, my dear students? Now take another example. Using the power series method, calculate inverse z transformation of the signals or the function x of z is equal to cos 3z. X of z is equal to sine z. X of z is equal to e power z plus e power 1 by z. And x of z is equal to ln of 1 plus a z inverse. And for all these 4 examples, ROC is greater than a only. Means first you can remember that you can write as ascending order of the powers of z power minus 1. What is the cos theta? We know the cos theta is equal to, actually cos theta is 1 minus theta square 2 factorial plus theta power 4 4 factorial minus theta power 6 6 factorial. This is a formula, my dear students. And sine theta is odd functions because the sine is odd and the cos theta is an even function. Theta minus theta cube 3 factorial plus theta 5 5 factorial minus theta 7 7 factorial and so on. And that summation is sum of, here the cos theta summation is sum of k is equal to 0 to infinite theta power 2 power k. So where the k is changes here, it becomes of 2 into k, 2k, and 2k factorial. 0 we can take, 1 we can take, it becomes of 2, 2 it becomes 4, and 3 it becomes 6, and so on. So minus 1, why it is a minus 1? Because alternately it changes the value is a plus and the minus and the minus and the plus. Minus 1 whole power k. If k is equal to 1, k is equal to 1, it is a minus value. K is equal to 2, the plus value, because it becomes of k is equal to 2. See here the theta power 4 plus value. K is equal to 3, it is a negative value, and k is equal to 4, again it is a plus changes. Okay, sine theta also you can write as sum of k equal to 0 to infinite minus 1 whole power k. Is alternately you'll get the negative and positive value. But theta I can see 2 power k is a even function, and you can add 1, it becomes of odd function only. K is equal to 0, you can substitute theta power 1, the first value you get, and k is equal to 1, you can substitute here 2 plus 1 is a 3, k is equal to 2, you can take 4 plus 1 is a 5 and so on. And it is a factorial is also satisfied 2k plus 1 factorial. Okay, the summation for the sine theta and the cos theta is the standard summation we have here. For the right sided, I'm taking here the right side because it is a greater than a, k is equal to 0 to infinite and 0 to infinite. Even the e power theta also, e power theta is 1 plus theta by 1 factorial, theta square by 2 factorial and so on. That is a sum of k is equal to 0 to infinite, theta power k by k factorial. And substitute the k is equal to 0 here, 1, and the 0 factorial is a 1, and theta 1 factorial, theta power 1 and the 1 factorial, theta square by 2 factorial, theta 3 by 3 factorial and so on. These are formulas you have to remember, my dear students. Whenever we get any function, the cos, sine, exponential and the ln function, logarithmical function, by using the power series, you can calculate the inverse Z transformation. Means use these formulas. Okay. At ln of 1 plus x, ln of 1 plus x, when x is less than the 1, so it satisfies this condition also. What is the expansion here? X minus x square by 2 plus x cube by 3 minus x power 4 by 4 and x power 5 by 5 and so on. This is x power 1 by 1. Okay, so on it increases. X power is increases and denominator value is also increases from 0 to. So summation is sum of k equal to 0 to infinite x power k plus 1 by k plus 1. Remember all the functions here. Cos is an even function, theta power 2k by 2 factorial. And minus 1 whole power k is because it is alternately you get the plus minus and so on. In the sine theta also, sum of k equal to 0 to infinite minus 1 whole power k. It is because it is getting the plus minus and so on. What is it? Odd function. Sine theta is odd. Cos theta is an even function. Theta power 2 power k by 2k factorial. And to add 1 for that function, it becomes of odd 2k plus 1 by the 2k plus 1 factorial. And e power theta is a theta power k by k factorial. and log function is x power k plus 1 by k plus 1. All the summation is right-sided only. The first I am taking the example of x of z is a cos 3z. What is a theta here? The 3z. Using this formula, substitute that as a theta as a 3z, sum of k equal to 0 to infinite minus 1 whole power k, 3z whole power 2k by 2k factorial. Expand the function when substituting the k is equal to 0. 1 minus k is equal to 0 means minus 1 whole power 0. Anything power 0 is a 1. 3z whole power 0 is a 1. And 2k factorial is a 1. 1 minus. Next one is a k is equal to 1. K is equal to 1 means it is a value is a negative value. 3z power 2 and 2 factorial plus, when if I am taking the 2 here, minus 1 whole square, it becomes of the plus. 3z power 4 by 4 factorial, 3z whole power 6 by 6 factorial, 3z 8 by 8 factorial, and so on. And z square, and here the z power 1, z power 4, z power 5, and z power 8, and so on. These are all, it is a positive powers of z, and see the coefficients. What is the coefficient here? The x of 0, and this one is a, and k is equal to 0 here. X of 2 coefficient, and this is a x of 4 coefficient, and x of 6 coefficient, and x of 8 coefficient. Got it, my dear students? So, and so on the values, you can write z power 8, z power 6, z power 4, z square, and the 1. Got it? Now the sequence is x of n is equal to, alternately you'll get the 0, 0, 0, and 0, and so on. And 1 here. And next one value is a 0. And the 9 by 2, because 3 square by 2, 9 by 2. And then the value here, 3 power 4, 3 power 4, and the 4 factorial. 4 factorial means 4, 3, 2, 1. 4, 3 is a 12, 12, 2 is a 24. 24 you'll get. And 3 power 4, 9, 3 square 9, 3 square 9, it is a 9, 9 is a 81. So on. Got it, my dear students? Because it is a powers is a positive powers. The sequence I wrote the x of minus, and x of all the x of minus k values only. So on from the negative minus infinity to 0. Got it, my dear students? Even if it is a greater than a is given, the series we got, it is a minus of so on the values. Okay. In the inverse Z transformation, the sequence x of n values. And second function, x of z is equal to sine z values. We know the sequence of sine theta, sum of k equal to 0 to infinite, minus 1 whole power k, theta power 2k plus 1 by 2k plus 1 factorial. Substitute the z, the z here, because the sine theta, we know the formula. Instead of theta here, the z is there. Sum of k equal to 0 to infinite, minus 1 whole power k, z power 2k plus 1 by 2k plus 1 factorial. Expand this function. Z minus z cube by 3 factorial, z power 5, 3 factorial, 7 by factorial, 9 factorial. And it is also the powers is a z, is a positive powers only. So the sequence here, x of minus 1, and this one is x of minus 3 coefficient value, and x of minus 5, minus 7, minus 9. So in between the values is a 0 there. Got it, my dear students? The 0 here, x of 0 is a 0, x of minus 1 is a 1, and x of 2 is not there, it is a 0, x of minus 3 is 1 by the 3 factor is a 6, 3 factorial directly write 0, because if there is no any 4 value and the 5 value is 1 by 5 factorial, no 6 value, 7 value is there, 1 by 7 factorial, we didn't get any 8 value, 0. Then after next we'll get the 9 factorial, 1 by 9 factorial, and so on. This is a sequence of x of n. X of n is equal to what, my students? Next, third example is that x of z is equal to e power z plus e power 1 by z. We already know this is a sequence. Sum of k equal to 0 to infinite theta power k by k factorial. Theta power k by k factorial. Using that sequence, e power z plus e power z power minus 1. Z power minus 1. First sequence, theta power k starts from the 0. So theta power 0 by 0 factorial, theta power 1 by 1 factorial. It is a sequence only, because not the even and odd function. So 1 plus e power 0, e power z whole power k. K is equal to 0. Anything power 0 is a 1. And then z by z factorial, theta, and z square by the 2 factorial, and z cube by 3 factorial. See, the e power theta is there. That theta only we are writing here. 1 plus theta by 1 factorial, theta square by 2 factorial. So instead of theta here, the z is there. So z by 1 factorial, z square by 2 factorial, z cube by 3 factorial, and so on. For the second function, instead of theta, that is a z power minus 1. So 1 plus z power minus 1 by 1 factorial, z power minus 2 by 2 factorial, and so on. Okay. Now combine the two functions, left-sided and the right-sided. Positive powers means they start from the minus infinite to write the equations as 1 by 4 factorial, 1 by 3 factorial, 1 by 2 factorial, and the 1. Okay, is a 1. And now the coefficients here, the z power 4, z power 3, z power 2, and the z power 1. 4 is a 1 by 4 factorial, 3 is 1 by 3 factorial, 2 is 1 by 2 factorial, and the 1 is z power 1. Z power 1 is a 1, and here is a 1 and the 1. Both are 0 values only. In this summation, it starts from the 0 here. In this summation, it is also start from the 0. So 1 plus 1 you can write as a 2. Got it, my dear student? And this 1 value is for the negative power of z is there. Z power minus 1 is a 1. And z power minus 2, 1 by 2 factorial. Z power minus 3, 1 by 3 factorial, and so on. Don't confuse why you got this a 2. That 2 will get for the 1 is here and the 1 is here. Both are, it is a 1 is equal to 0. 1. I wrote this negative positive powers as from minus infinite to. You get the z power minus of minus 4 when n is equal to minus 4. So on. The sequence will get. Got it, my dear students? And these are all the coefficients only. When you can write these coefficients as a summation, sum of n is equal to, or n is equal to minus infinite to infinite. Write this function because z power is there. Z power minus n. Z power minus n means it start from the minus infinite to the minus infinite. And we'll get the coefficients. 1 by 4 factorial, 1 by 3 factorial, and 1 by 2 factorial, and multiplications. The factorial will get at 1 by n factorial, I take n factorial. So 4 factorial factorial, 3 factorial, and so on, the positive values, the negative values. But the negative values also will get the positive values only. Both it is a n factorial magnitude of, got it, my students? So on, we'll get all the values when we can take as a summation. And the next function, ln of 1 plus a z inverse. Ln of 1 plus a z inverse. So what is the sequence here? Ln of 1 plus x is there. X minus x square by 2, x cube by 3, minus of, alternately you get the minus, and it's increasing x of k plus 1 by k plus 1 from 0 to infinite. Okay. Now what, instead of x, there is a z inverse. A z inverse. Okay, a z inverse minus a z inverse square by 2 plus a z inverse cube by 3 plus minus, alternately the minus is there, and a z inverse whole power 4 by 4 and so on. See, these are all, it is a negative powers. So the coefficients is x1, x2, of 2 is minus a square by 2, a cube by 3, minus a4 by 4, and a power 5 by 5 and so on. Got it, my students? Then x of z is equal to sum of n is equal to minus infinite infinite minus a z inverse whole power n. 1 is equal to, because it is an increasing order, minus a z whole power minus 1 whole power n. Expand this value. When n is equal to 1, it becomes of a z inverse. When n is equal to 2, minus a z inverse whole square. And n is equal to 3, minus a z inverse whole cube, and so on. Got it, my students? This is a sequence to get the negative powers of z. And then changing this value as minus a whole power n and z power minus n minus 1 into n, nothing but z power minus n. Already the minus is there, you can keep this a minus in front, minus value here. And then the minus of sum of n is equal to minus infinite to infinite. I change this as 1 to infinite as minus infinite to infinite. Means one sample is shifted towards the right side. Mu of n minus 1 minus a whole power n z power minus n. So what is the x of n here? Minus of minus a whole power n mu of n minus 1. X of n is equal to minus of, not the minus, not the minus of, minus of minus a whole power n mu of n minus 1. Got it, my students? Okay. Once it is a greater than a, we get the positive powers of the z. And in this expansion, we can write all it is a functions, square value, and whatever the factor is there, the square n power n is also you can get here, my students. Actually, is a function as by n also. By n. Then only you'll get this a when n is equal to 1, and n is equal to 1 minus a z power minus n by whole power n by n. 1 will get. What is the second function here? Square means, if I take the square is the minus, whatever we have, the minus is there, you will get the plus, and before that I substitute the minus here. So the second value is a minus a z power minus 1 whole square, and the 2 is there here, because when n is equal to 2, I substitute 2 also. So by n, when I substitute the 3 means this minus value and this minus value becomes a plus. When I'm using the 4 here, n is equal to 4. 4 means there is no the minus whole power 4 is a positive value, and with this minus they will get the minus value. So in this function there is a n is also there. You can write this. So what is the x of n? Minus of minus a whole power n divided by n also. N with the mu of n minus 1. Modify this, my dear students. After listening this, if I send the material, there is a wrong with the function. The function is minus a z power minus 1 whole power n and divided with the n also. Got it? So next method, you go for the next method, that is a partial fraction expansion method. Until now, we discuss about the long division method and the power series method. You can remember the cos z, cos theta, sin theta functions and the exponential function e power z and the log of 1 plus x also, ln of. Using that sequence series is write the summation of x of n to get the time domain function x of n value. The second method is a very easy method to find out the inverse Z transformation. Mostly we are using a partial fraction method only to find out the inverse Z transformation. An easy way, we already know how we can find out the partial fraction expansion for the any given function with the quadratic expression and after finding out the roots. Okay. If x of z is a Z transformation of x of n, then calculate the partial fraction for x of z by z, x of z by z in the function as a x of z. First of all, write the x of z in terms of x of z by z. Distinct poles. X of z by z has a distinct poles. Let it be the c1 by z minus 1, c2 by z minus b2. We are always taking the a by z minus a minus z minus b, b by z minus c, and so on. Okay. But taking that is x of z by z and with the coefficient of x of z minus p l, the cl is equal to, substituting of z is equal to pl, or the pi it is. Ci is equal to z minus pi and xz of z, x of z by z. Substitute that whatever the value we have here, the z is equal to pi. To get it is a ci. Ci means c1, c2, c so on. C1 means z minus p1. C2 means to get the C2, z minus p2, and that value is a p2 is also substituted. Second method is repeat the poles. Okay. And third way we have repeated poles means z minus c1k, z power p minus k, z power, whenever if it given the z minus z minus 2 whole square repeated poles. Whole square means you can write as a ck1 by z minus pk and the ck2 by z minus p suffix k whole square and so on. When you'll get the repeated poles, you can write the cky and cky, the two values we have, by taking out the differentiation also, the partial differentiation. If suppose in this function any complex poles we have, that complex poles means that also you can write as a complex conjugate, the c1 by z minus p1 plus the c1 conjugate by z minus p1 conjugate. Find the poles of conjugate poles, you can substitute and find out the equation in terms of the standard equations. In terms of the standard equation, to write the inverse Z transformation is the easy way. First of all, there is a three ways you can find out, not the three ways. The given function having the distinct poles, you can follow this one. In the given function, you have the repeated poles, you can follow this. And if the given function will expose partial fraction expansion method of inverse Z transformation, x of z is equal to z power minus 1 by 3 minus 4z inverse plus z power minus 2. First of all, you can, given function is in the negative powers of z, change that is a positive powers of z. Change that is a positive powers of z. So see here, 1 by z square, 4 by z, and 3. So you can write as a 3z square minus 4z plus 1. And the numerator having the z power minus 1 is there, that is a 1 by z. And in the denominator function also 1 by z square. So 1 by z by the 1 by z square means we'll have the z only. So z by 3z power minus 3z square minus 4z plus 1. Find the roots for this one by using this minus b plus or minus square root of 4 b square minus 4ac by 2a. Okay. After finding out the poles here, what is our poles? We got 1 and 1 by 3. 1 and 1 by 3. Means x of z. You can bring this z towards the left hand side, x of z by z. Always you can write the z transformation by the x of z by z form only. Is a 1 by 3z square minus 4z plus 1. What are the roots? We got 1 and 1 by 3. So z minus 1 and z minus 1 by 3. So multiply this function z square minus z minus 1 by 3. So minus 1 minus 1 by 3 is 3z. We can write as 3z minus z and minus 3z. We will get the same thing. Okay. Multiply these two. The 3z minus 1 like this. Or you can write as 1 by 3 as is the factors is a 1 by 3 or not. First of all, you can see the minus 4 plus or minus 1 whole square, and is a b square is a 16 minus 4ac. 4a is a 3. 16 minus 2 is 16 minus 12 is a 4 plus minus b. Minus b is a plus 4 here. The 4 plus or minus 16 minus 4 is a 2. 2 by the 2 into 2 a square minus b plus or minus square root of b square minus 4ac by 2a. 2a here it is a 3. And 4 plus or minus 2 is a 8 or the 8, 6 by 6. Another function is 4 by 2. 4 minus 2 is there. Minus 2 is a 2 by 3. 2 by 6, nothing but is a 1. So 1 and the 1 by 3 only. 1 and 1 by 3. We take this as a 3 by z minus 1 and 3z minus 1. Okay, it is a z square, 3z square, and minus z and minus 1. Minus into minus is a plus, and 3 will get is the extra value here. Okay, so the two factors we got, the two factors you can write as a z minus 1 and the z minus 1 by 3 only. Z minus 1 by 3 is a, you can write as a z minus 1 by 3 and is a z minus 1. So rewrite this function as a by z minus 1 plus b by z minus 1 by 3. z minus 1 by 3. You see, the 3 is also will get here, multiplying the 3, then only it is a cancel of 3 and 3. So a by z minus 1 plus b by z minus 1 by 3. To find the a and the b values, you can comparing the z coefficients or whatever it is, directly can substitute z minus 1 by the total function we have. X of z by z is 1 by 3 into z minus 1, z minus 1 by 3. Z minus 1 and z minus 1 get cancelled. You can substitute z is equal to 1 in this function. So 3 into z minus 1 by 3. So 3, 1 minus 1 by 3. So take the 3 minus 1, 2, 3, 3 get cancelled. So 1 by 2 is the value of a. And b is equal to the same thing, z minus 1 by 3 and x of z by z. So z minus 1 by 3, z minus 1 by 3 get cancelled in this function. 1 by 3, z minus 1 is there. So 3 and 1 by 3 can substitute as z. So 1 minus 1 by 3 is there. 1 minus 3 and 3, 3 get cancelled, minus 2 in the denominator. So b is equal to minus 1 by 2. So a is equal to 1 by 2 by z minus 1 and b is equal to minus 1 by 2, 1 by z minus 1 by 3. Got it, my dear students? So 1 by 2 into 1 by z minus 1. So take this x of z as a multiplication factor of z by z minus 1 and z by z minus 1 by 3 and convert into the negative powers of z. Take the z is a common here. Take the z is a common. The first function becomes of 1 by 1 minus z inverse. And second function is becomes of 1 by 2 into 1 by 1 minus 1 by 3 z inverse. Since it is a greater than the ROC, you can write all the functions greater than the ROC function in the mu of n values only. 1 by 2 into, what is the a here? 1. So 1 power n mu of n minus 1 by 2 into, what is the a here? 1 by 3. So 1 by 3 whole power n mu of n is a inverse z transformation for the given function x of n is equal to, see here, a power n mu of n. And second function, they wrote that is a less than a. But actually, if the given depends upon the given value only, you have to write down the function. Okay. Finally, see here, x of n is 1 by 2. Take the 1 by 2 as a common. Mu of n minus 1 by 3 whole power n mu of n. You can take the mu of n is also common term is, you'll get here the 1 by 2 into 1 minus 1 by 3 whole power n mu of n only. Okay. Because it is a greater than, if it is a less than a, you can change this function as minus a whole power n mu of minus n, and here also minus a 1 by 3 whole power n mu of minus n minus 1. Depends upon the ROC, the value is changes. So when the ROC is in the z is less than the 1 by 3, irrespective of the value here, if it is a less than, write the two functions as a left-sided only. One is a minus 1 power whole power mu of minus n minus 1, minus 1 by 2, minus 1 by 3 whole power n mu of minus n minus 1. Take the mu of minus n minus 1 is a common. 1 by 2 is also common. Here now, because it is a minus is there in the before the value of time domain function, 1 by 3 whole power n minus 1. Simple by saying that, seeing that is a mu of minus n minus 1 is a left-sided, is less than, z is less than. Here the mu of n is there, it is right-sided, z is greater than. Right-sided, z is greater than. So combination of, if it is greater than 1 and the less than 1, if both are combining them, Combining means now you can see the value. If 1 is there, we can write that function as only the greater than in terms of mu of n. Wherever the 1 by 3 is there, you can write is a less than 1. Follow my dear students, less than 1. So in the given example, the ROC they are asking is 1 by 3 less than Z and less than 1 by 2. So 1 by 3 less than Z and less than 1 means Z is greater than 1 by 3 and Z is less than 1. Wherever the value is there, depends upon that ROC you can write up. 1 means 1 by 2 minus 1 whole power n mu of minus n minus 1 is a, for the Z is less than 1 because the value is there 1 here. And second term minus 1 by 2 is there, value is greater than. So 1 by 3 whole power n mu of n. So combining of right sided and the left sided function. When Z is greater than means total function you can write in the right side only. Mu of n is multiplied. Z is less than 1 by 3. The total function is multiplied with the mu of minus n minus 1. But in the range you can take given, and depends upon the value where it is present. Take it as greater than 1 by 3 as mu of n minus n and minus 1 it is. Wherever the 1 value is there, you can write as mu of minus n minus 1. Got it? See this. The last 1 by 2 into minus 1 whole power n mu of minus n minus 1 minus 1 by 2 1 by 2 whole power n mu of n. All the three terms. One time is a greater than, another time is a less than, another time is a range. Okay, my dear students. So any doubts up to this? Okay, thank you.